basic design of a polarimeter has four components: a linearly polarized light source, the sample chamber, a rotatable polarization analyzer, and a light detector. In the polarimeter you will construct, the light source will be a linearly polarized red diode laser, 636 nanometers. The sample chamber will be a tall tube. The analyzer will be a square of polarizer film mounted on a rotation stage, and the detector will be your eye. The rotation analyzer has already been attached to a ring stand for you, so construction of your polarimeter begins by securing the ring stand just above the light shield box. You will want to place a blank white sheet of paper under the view box. The glass tube or sample chamber will then be held with a barrette clamp. Make sure the tube is held perfectly straight, and position the clamp so that the glass window at the bottom of the tube is just above the polarizer film on the rotation analyzer. The final step is to install the diode laser. These lasers are powerful enough to cause eye damage, so make sure that you do not turn the laser on until it is mounted securely on the stand and pointing down towards the lab bench. You will place the plastic adapter laser assembly on the top of the glass tube. Rotate the plastic adapter so that the marks on the adapter and the glass tube align. Next, you will stabilize this alignment with the Scotch tape. Have your laboratory instructor make sure to check your polarimeter setup before continuing. Experiment with the rotation analyzer. You can look into the viewing box and rotate the analyzer until you see the transmitted light is minimized. Once recorded, you can go ahead and turn off the laser, and take off the plastic adapter and laser assembly, and next you can use a funnel to facilitate filling your tube with your sucrose solution nearly to the top of the tube. You can add the last milliliter or so of your solution using a syringe pipette so that the tube is filled to the very top and the meniscus is as flat as possible. Solution in the tube. Afterwards, you will replace the plastic adapter, line up the marks again. At this point, you can turn the laser back on and then measure the new angle at which the transmitted light is minimized. To begin your sucrose hydrolysis kinetics measurements, you will measure out 20 milliliters of your remaining sucrose solution with a graduated cylinder and pour this aliquot into a 100 milliliter beaker. Once your experiments begins, one member of your team will be the timer and recorder, and the other member will observe and report rotation angle. When you are ready, add the 6 milliliter portion of HCl solution into the beaker. Swirl the mixture and then pour it into the tube. The clock starts the moment the HCl is added to the beaker. Next, you will place the plastic adapter / laser assembly on top, turn on the laser, and adjust the rotation angle of the polarizer to attenuate the laser light. Try to make this initial reading as quickly as you can. The recorder should note the exact time at which the reading is made, Continue recording rotation angles every 2 minutes for at least 30 minutes. When you're all done, turn off the laser and make sure to dispose of waste chemicals in the hood and disassemble your polarimeter.